From our previous homework textbook page 68, question 4. 2x squared minus 1 times 3x plus 2 can be written as the divisor 2x minus 2 multiplied by its quotient plus the remainder. So if you are only interested to find the remainder, from the previous topic, we learned that the degree of this expression, which is the highest power of x, is 3. Then the degree of the divisor is 1, which means the degree of the quotient is 2, because 2 plus 1 makes 3. So do you know what is the degree of the remainder? So the degree of the remainder is 1 less than the degree of the divisor, which is 0. Now if we just want to find the remainder r, that means we try to get rid of here and make this 0, right? So to make this 0, we let x be 2. When x equals to 2, so it becomes 2 times 2 squared minus 1. 3, 2 plus 2 equals to 2 minus 2 qx plus r. So we don't have to care what is qx because 2 minus 2 is 0 and this whole product will become 0. So from here we have the remainder is 56. So remainder is 56. So we see that to get the remainder, we just need to substitute x is 2. That is, we try to make the divisor equals to 0. So this is where we are going to the next section, which is remainder theorem. Similarly, for question 1 from our previous homework, when 9x squared plus 6x plus 2 is divided by 3x minus 2, we can write 9x squared plus 6x plus 2 is equals to 3x minus 2 times its quotient plus the remainder. So if we are only interested to find the remainder, we need to set 3x minus 2 as 0 so that we can get rid of the quotient. The value of x when 3x minus 2 is 0 is not just 2 but 2 over 3. So now the divisor is 0 and we can find the remainder. Which brings us to the next section, 3.3, remainder theorem. So remainder theorem says that when fx is divided by x minus a, the remainder is fa, because we're trying to make the divisor 0. So x minus a is 0, therefore x is a. For example, our question number 1, we have fx is 9x squared plus 6x plus 2, and we are trying to divide the function by 3x minus 2. So in this case, we make 3x minus 2 is 0, so x will be 2/3. So that means the remainder when fx is divided by 3x minus 2 is f 2/3. Now let's look at the example from page 71, question 1. We want to find the remainder when the polynomial is divided by x plus 1. So to find the remainder, we let x be -1 so that x plus 1 is 0. So a, first let fx be the polynomial, which is x power 4 minus 4x power 3 plus 3x squared plus x plus 3. So the remainder when fx is divided by x plus 1 is f -1, and we just substitute x as -1, then we will get the remainder 10. Now it is your turn to use remainder theorem. to find part B. So for part B, we want to divide fx by 2 minus x. So we want to make the divisor 0. 2 minus x is 0, so x is 2.